Yeah. So basically, if I am taking a white screen, okay, I just have to write 1 1 0 0. What is the value of this? Uh, just 1 minute. Vanishing pen. मैंने भूल से vanishing pen use कर दी थी. I have to use. Okay. So if I am using what 1 1 0 0, what is the place? What is the value of this in decimal?
12.
Very good. 1 0 0 1. What is the place value of this? Sorry.
1.
Yes.
9.
Very good. So, see what happened जब मैं ये चीज पूछ रहा हूँ तो आपके माइंड में क्वेश्चन आ रहा है और सबके सामने से आंसर नहीं मिल रहा है. इसका रीजन क्या है? Because some people are not knowing that each and every binary digit is actually given a decimal, or you can say the place value. Now the place value of this is how much? Anyone can tell me what is the place value of this? 1. What is the place value of this? 2. What is the place value of this?
4.
What is the place value of this? 8. What is the place value of this? 16. What is the place value of this? 32. Understood or not? So basically, each and every place value is indicating that if I am telling you you want to write the place 10. So what is the binary of 10? So what you will do? You will just add the place value. 8 plus 2 will give you what? 10. So you will be getting 10. So you can see here, whenever you are considering this thing, the 4 place value will be 0 and the place value of 1 will be 0. So your answer will be 1 0 1 0. If I am telling you want to find the value of 9, what is the binary of 9? So what you will do? You have a 8, 4, 2 and 1. So 8 plus 1, 9. So obviously the place value of 8 will be 1 and for 1 it will be 1. So other will be 0. So it will be 1 0 0 1. Understood or not? But when I'm talking about 6, so what is the place value of this? 0 1 1 0. What does it indicate? 4 plus 2, that is equals to 6, isn't it? So it will be very easy for you to make a binary number, and you are actually learning this subject. The reason behind that your machine don't understand the normal language. Okay, it don't understand the English language, but it only understands the machine language. So you have different types of languages like high level languages and low level languages. Okay, where high level languages are, you know very well that machine languages are nothing but they are called binary coded language, which is having a binary number 0 or 1. Is it clear, guys? Understood? Okay. So basically, we are studying digital electronics because we have to understand the basic fundamental of machine language, how our machine understands the thing, and if you want to make any complex calculation easy, okay. For example, you just gone through the different aspect of digital electronics, like how to find 2 complement, how to find 1's complement. Okay, you also understand the law like associative law, then डिस्ट्रीब्यूशन लॉ एंड देन डी मॉर्गन्स थ्योरम जो आपने 12th स्टैंडर्ड में पढ़ा हुआ है, डी मॉर्गन्स थ्योरम. तो ये सारे थ्योरम्स भी आप लोग ने पढ़े हुए, पर वो जनरली क्या होता था, कॉम्प्लेक्स हो जाता था. इट वाज वेरी डिफिकल्ट फॉर यू टू सॉल्व एनी एग्जांपल यूजिंग डी मॉर्गन्स थ्योरम. Okay, so what you were doing, you were just like making that small calculation. But if you want to make a large calculation, you have to use the Carnot map. So today we are going to learn this Carnot map. Okay, so first of all, why we are using this Carnot map? The most important thing is that we are using this Carnot map because it is very easy for us to simplify the Boolean function. Okay, we can do the calculation very fast. Not only that, whenever we are using identities, okay, it is very time consuming and there may be chances of getting error. So if you want to reduce the time and if you want to reduce the error, you can simplify your Boolean functions using this Carnot map method. This is one type of tool only or method you can say by which you can make any calculation easy. Okay. Next, then comes as this is a special section present in essay. Okay, you can see here the systematic methods are used. This is a systematic method which is actually used for reducing a Boolean expression. We will see that how this method is used. Okay, this method was actually developed by Carnot only, Maurice Carnot. Okay, and in 1953, he was a telecommunication engineer and he has developed at Bell Laboratory. Okay, the most important thing was that this was actually invented because they were actually working on a telephonic circuit. Now you know very well telephonic circuit की बात करो अगर आपने कभी किसी टेलीफोन को रिपेयर करने के लिए ओपन किया होगा तो उसकी सर्किट जो होती है वो बहुत कॉम्प्लेक्स होती है. ओके, सर्किट की कॉम्प्लेक्सिटी इतनी ज्यादा होती है कि जब हम लोग कोई किसी नंबर को डायल कर रहे होते हैं फोन में, है ना, आपको पता है पुराने जो डब्ले आते थे उसके अंदर नंबर्स होते थे, तो जब नंबर्स हम लोग डायल कर रहे होते थे तो पर्टिकुलर नंबर पर्टिकुलर जगह पे वहां पे लिंक होता था. ठीक है, तो इट वाज ऑल अबाउट नेटवर्किंग. ओके, बट नेटवर्किंग वाज आल्सो डन विद द हेल्प ऑफ डिजिटल लॉजिक ओनली. But the coding was actually which was it was in the form of digital logic only. You can say that binary numbers only, and it was very important to solve that design with this uh, technique, and that's why we it was invented by which way we can make the calculation easy and simplify the circuit. Okay, so this is how we can see the application of डिजिटल लॉजिक. आप डिजिटल लॉजिक का किसी भी एप्लीकेशन में देखोगे तो कंप्यूटर आजकल हर जगह यूज हो रहा है ना, आपको पता ही है. आप कंप्यूटर ऐसा नहीं है कि पर्टिकुलर आप कंप्यूटर ही यूज कर रहे हो, पर कंप्यूटर के एप्लीकेशन जो है वो अभी मैक्सिमम हर जगह यूज होती है. आपने रेस्पबेरी पाई के बारे में सुना हुआ है. एक रेस्पबेरी पाई का सिर्फ आप मॉड्यूल ले लो, आप अपने टीवी को कंप्यूटर में कन्वर्ट कर सकते हो. ठीक है, तो इट इज वेरी इंपॉर्टेंट बिकॉज कंप्यूटर इटसेल्फ इज नथिंग बट it is one type of you can say that it is having a brain, that is called CPU, central processing unit. Okay, and whenever you are attaching your CPU with a monitor, okay, it becomes a computer. So same way this application or digital logic application is used everywhere, all the electronic circuit, anywhere in the electronic circuit we are sending our data in the form of digital only. Why we are not sending our data in the form of analog? The reason behind that is there are chances of getting error, or you can say that the noise. Okay, the simple word we can use noise. What is noise? Noise is nothing but unwanted signal, है. So it happens the noise is not actually decoded, but whenever having a digital signals, the signals become very clear, and it whatever signals you are sending from the sender side, it is received on the receiver side. Is it clear, guys? So this graphical representation is nothing but this is known as Carnot map or K map. Clear? Any doubt till now? Are you clear about this? Okay, this is the history of Carnot map. Why it was developed? Carnot map was developed so that we can solve the complex circuit. And as you know that generally we are sending all the digital signals from the electronic devices, and these digital signals, how they are flowing from sender end to the receiver end, you should be aware about this. Okay, next. So generally when you're talking about K-map, K-map is actually considering there are two terms, that is mean term and max term. Okay, you should be very clear about this mean term and max term. And when you are talking about K-map, it is consist of matrix form. Okay, now what is matrix form? I will just show you with the help of whiteboard. see how it is prepared. Uh, for example, I want to make a graphical representation of a K-map, okay, of any number. So I can do for the 3 variable, I can do for the 4 variable. It depends on you, whichever variable you want. Okay. For example, I am taking a 4 variable. Okay. So I will be having a matrix of 4 by 4. Is it clear, guys? Now, whenever I am going to put the values of this, okay, this this will plays a very important role. If suppose I'm having a variable A, B, C, and D. So I'm having a variable of A, B, C, D. So I can put the 2 variable on this side, A, B, okay, and the another 2 variables on this side, that is C, D. Now you will be having question in mind, sir, why you have put an AB here and CD here? It's not compulsory. You can interchange the pattern, but the most important thing is that whenever you are writing the values, okay, at that time you have to be clear that how to write that value. For example, I'm writing here ABCD. So this is very important that when I'm taking this one, now, for example, I'm taking here 0, 1, 2, 3. Okay, we are just considering this one 0, 1, 2, 3. Now, how I have written this 0, 1, 2, 3? 0 indicate that my A, B, C, and D will be having bar. Why? Because you know very well A expression indicate 1 and A bar indicate 0. I don't have to repeat this. Dana, you have studied this thing. This is called complement of 1. So if I'm considering my A as a 1, that is my switch is on. Okay. For example, I am taking here a bulb. Okay. See, actually, I'm showing you the application, how this actually works. And I'm having here a switch. Okay. Which is connected with a battery. Is it audible, na guys? See, if you have any doubt, you can
Yes,
ask
sir.
me. You can interrupt me anytime.
Yes, sir.
So basically, if suppose I'm taking one circuit and I'm taking one circuit with a switch, I'm connecting with a battery. Now, if someone is asking you what is the condition or what is the uh, like what is the condition of this switch, so you can say that, sir, it is actually A bar is equals to 0, or you can say S bar is equals to 0. Okay, it indicates that my switch is open. That's why it will be giving 0. Okay, but when the switch is closed, you can say that it is on. So you have to remember in digital electronics, 1 indicate on and 0 indicate off. Okay, so this is how you can relate your circuit. Generally, digital electronics were also used in electrical circuit too. If you want to make any application, you can use with the help of digital electronics. You can do this thing also. Okay, so I have written here 0, 1, 2, 3. It indicates that my A, B, C, D will be having the value A bar, B bar, and C bar, D bar. Okay, so if I'm writing the value A bar, B bar, C bar, D bar, so what is the value? All will be 0. There will be total 4 zeros. Clear, guys? Why? Because A bar, B bar, C bar, and D bar, they all are having the 0 value. So you got here 0. Understood? Now, if I am talking about this one, what is the value of this term? Okay, so how can you represent this? So basically, you have to see that value of if I am taking this value as a B, C, and D, and I am making A bar, B bar, C bar, and D. So what does it indicate? 3 of the term will be 0, and the last term will be 1.
1.
Okay, so what can be the value of here in this term? Anyone can guess what will be here? ये 1 को अगर रिप्रेजेंट करना है तो यहाँ पे सी बार डी बार की जगह यहाँ पे क्या आएगा, सी बार डी। इज इट क्लियर गाइस? तो हुआ क्या, ए बार बी बार सी बार डी, that is equal to how much? We have just derived this one, that is 1. Now next can be what? 1 के बाद क्या आता है? 2. Okay, so if I am going for 2, how can I write down 2? A B C D. तो यहाँ पे मुझे अगर 2 बनाना है तो कैसे बनेगा? यस, ए बार बी बार C and D, isn't it or not? So basically what happened in this case, whenever you are talking about A bar, B bar, C and D, so you have to make this bar. So here it will be CD bar. Okay, so if you are writing 0, 1, 2, 3, then it will be making here in this format. Understood? Like I just show you one more example. Just 1 minute. Like we can see here. See, this is the same thing which I want to explain you through the Carnot map. For example, here you are having mean term which is having the function x and y. If I am writing x bar, y bar, what does it indicate? That what is the value of x? 0. What is the value of y?
0.
It will be 0. If I am
0.
writing x bar, y, what does it mean? 0, 1. If it is x, y bar, then it is called 1, 0. If it is x, y, so what does it mean? 1, 1. So basically, when you are writing these functions, you can write down that this is called mean term. Mean term indicates what the value of bar will be 0. So if you are having x bar, it means it is 0. If it is x, then it is 1. Okay. Is it clear about mean term?
Yes, sir.
Yes, sir.
Okay. Mean term सबको समझ में आया? Bar indicates 0 value. Now see the same thing for the 3 inputs. If I am having 3 inputs, so what will be the value? X bar, Y bar, Z bar. तो क्या हुआ? 0, 0, 0. If I am writing X bar, Y bar, Z, तो 1. अभी हमने ये डिस्कस किया था. ठीक है? फिर X bar, Y, Z bar. So what is the value? 0, 1, 0. X bar, Y, Z. 0, 1, 1. It is how much? 0, 1, 2. अगर हम इसका वो लिखने जाएं, क्या बोलते हैं? वैल्यूज, तो आप इसका वैल्यू क्या लिखोगे? डेसिमल. इट इज 0, दिस इज 1, दिस इज 2, दिस इज 3, दिस इज 4, दिस वन इज 5.
5.
x y bar z, x y z bar, this is 4 plus 2, 6, and x y z is 7. Is it clear, guys? So this
Yes,
diagram is actually explaining you that how we can represent our mean term. How we can represent our mean term. Okay. Now this is one of the example which we are going to solve with the use of K-map. Okay. I have just taken the two variable x and y. Now I want to do the which operation it is done. You learn this operation in digital logic. This is called AND operation. This is called. Have you learned the gates or not, guys?
Yes, sir.
Yes, sir.
Yes,
So
sir.
why are you late? Be on time. Okay. So basically, you know very well. You have learned the gates. You have learned the AND gate. You have learned OR gate. You have learned NOT gate. So when I'm talking 0.0, it is giving you 0. When I'm talking 0.1, it is giving you 0. When I'm talking 1.0, it is giving you again 0. But I am writing 1.1, then it is giving you 1. Okay. If I want to represent this whole circuit on the K map, I just have to take the variable as we have discussed in the white map, that x is written here. I am taking y on this side. Okay. So first one will be x bar. Similarly, it will be y bar. Okay. So you can see here, so x bar, y bar. X bar का value 0, y bar का value 0. 0, 0 आंसर कितना आया? 0. Understood? ये क्या हुआ? Y. Understood? So अभी यहाँ पे हम लोग क्या कर रहे हैं K मैप में? 0.1 इसका वैल्यू 0, इसका वैल्यू 1, 0.1 कितना होगा? 0 होगा। तो आंसर क्या लिखा? 0। अब यहाँ पे देखो नीचे x डॉट वाई बार, आंसर कितना होगा? 0 एंड
0
x डॉट वाई आंसर कितना हुआ? 1।
1.
तो हमने क्या किया, जो हम लोग गेट में लिखते थे उस गेट को हमने सिंप्लीफाई करके के मैप में लिख दिया। मतलब वी आर जस्ट सिंप्लीफाइड दिस गेट। ये तो सिंपल गेट है, पर अगर कॉम्प्लिकेटेड गेट आता है तब आपको उसको सॉल्यूशन निकालना है, तो इट विल बी वेरी डिफिकल्ट फॉर यू। So if someone is asking you, okay, just see this. What I want to actually show you. I just remove all this thing, है ना? Now you just for some time you just forgot this one, है ना? Which one? I just want to say that you forget this answer. This one you don't remember this answer. Okay. And if someone is asking you, okay, this is a K map which you have written, and you want to find the solution, obviously your solution will be that wherever 1 will be there, the expression will be that, है ना? So for f of x comma y, this is the function f of x comma y. What will be the output of this function? Obviously, where you will be getting the output 1, that will be the function. So it will be x, इसका x और इसके वाले का y. So answer will be x dot y. Is it clear? तो जो चीज हम रिवर्स कर रहे थे तो भी आंसर सेम आएगा, के मैप को सॉल्व करोगे तो भी आंसर वही का वही सेम आएगा। मतलब ये क्या होता है, कंडीशन प्रूव हो जाती है। यू कैन सॉल्व दिस एंड गेट यूजिंग दिस टेबल, यू कैन सॉल्व दिस एंड गेट यूजिंग दिस के मैप। Now the next one, this is about OR gate. You have studied OR gate also, na? If I am writing 0 0 0 1 1 0 1 1, so how you will say 0 plus 0 0, 0 plus 1 will be 1, plus 0 1, 1 plus 1 1. Same यहाँ पे करो 0 1 0 1, so 0 plus 0 0, 0 plus 1 1, 1 plus 0 1, 1 plus 1 1.
2.
Or not? पर यहाँ पे आपका आउटपुट क्या आएगा? ऑब्वियसली देखो, अगर आप यहाँ पे देखेंगे तो एक आपका आउटपुट यहाँ पे 1 इधर आया है, तो इसका एक्सप्रेशन क्या है? x बार y, ठीक है। इसका एक्सप्रेशन क्या है? एनीवन? इस वन का एक्सप्रेशन क्या है? यस
x y बार,
यस, वेरी गुड, इट इज x y बार। देन लास्ट वाले का यू नो वेरी वेल, x इंटू वाई। तो आपका आंसर आया x बार y प्लस एक्स वाई बार प्लस x इंटू वाई। अब इसमें से आप क्या करोगे? तो आप सिंपल कॉमन ले लो, x बार y प्लस एक्स वाई बार, है ना? दैट इज इक्वल्स टू 1, यू नो ना, x बार y प्लस एक्स वाई बार इज इक्वल्स टू 1. So your answer will be what? In this case you have to take the common. Now you can't take here from common, you have to take this one and this one common. So x bar y plus x into y. So when you're taking y common, it will be x bar plus x. What is the value of x bar plus x? Anyone can tell me? What is the value of x bar plus x? Yes.
क्या सर?
What is the value of x bar plus x? Whenever you are finding the value of x bar plus x, it is a, when you are taking this common, y will be the common, है ना? y will be common or not in this case? अगर आपने x bar y लिया और x into y लिया और y common लिखा, तो अंदर क्या बचेगा? क्या बचेगा?
x बार प्लस x,
y बचेगा ना? Understood or not? So in this case, this one. In this case, it will be what? X bar plus x, and you know very well the value of x is 1 and x bar is 0. Okay, so generally when you are writing this condition, you have to remember that OR functions indicate that you have the combination of x and y, and you are adding the two sums. Okay, so this is the equivalent values. Understood? Next one. For example, I am taking this one. I have the two groups x, y, 0, 0, 0, 1. So you just remember, एक तो आपको 0 लेना है, दूसरा आपको 1 लेना है. सेम यहाँ पे 0 लिया, यहाँ पे 1 लिया, और दोनों का वैल्यू लेना है. यहाँ पे आपको और गेट ही दिखाया हुआ है. अब यहाँ पे इन लोग ने क्या किया हुआ है, दोनों का कंबाइन किया हुआ है. इसका एक कॉमन लो, इसका एक ग्रुप बनाओ. तो इसे बोलते हैं सिंप्लीफिकेशन. नाउ वी आर एक्चुअली सिंप्लीफाइंग दिस. ये जो है ना, ये जो मैंने लिखा, इस चीज को मैंने यहाँ पे सिंप्लीफाई किया है. सिंप्लीफाई कैसे किया है, ये ओवरलैप हो रहा है. एक यहाँ पे एक ओवरलैपिंग आ रही है, एक यहाँ पे एक ओवरलैपिंग आ रही है. जब आप इसके आगे करोगे तो आपको ये देखना है कि पर्टिकुलर ओवरलैपिंग कितने बार हो रही है. तो 2 बार हो रही है. इसलिए हम यहाँ पे देख सकते हैं कि बताऊं, हम यहाँ पे जो आउटपुट आता है वो x plus y आता है ड्यू टू दिस ओवरलैपिंग. दिस टर्म इज ऑल्सो ओवरलैपिंग and this term is also overlapping. So this one is actually overlapping to each other. Understood? And that's why the overlapping term is removed. When the overlapping term is removed, तो यहाँ का क्या बचेगा? Obviously x, और यहाँ का क्या बचेगा? y. So it will be x plus y. Is it clear? See, so this should be these are the rules which you have to remember for K-map. First of all, grouping can contain only one, no zeros. Zeros का grouping नहीं होना चाहिए. आप बोलोगे कि यहाँ पे भी सर grouping कर सकते हैं. No, only grouping will be done with the one only. They cannot be done with the zero. Grouping is only done by one. This is the most important thing. Second, grouping can be only done at right angle. As you can see, we have not done this grouping. Right? You can see the diagonal grouping is not allowed. Okay, so whenever you're doing, it should be at right angle. Okay, now the number of ones in the group must be the power of 2. Even if it contains one, okay, single one, but it should be the power of 2. And group must be as much as large possible. जितना बड़ा हो सके ना, क्योंकि जितना बड़ा ग्रुप रहेगा ना, उतना ज्यादा आपका सॉल्यूशन आउटपुट आएगा. Understood? So it is very important which you have to understand. This is now for 3 variables. You can see here what I have done. You just have to remember. For example, I am taking here x and I am taking yz. X is 0, x bar. This is x bar. Sorry, this is x bar. This one is x. Okay. Just 1 minute. Yeah. So this is x. This one is x, and this is x bar. This is 0, 0, 0, 1, 1, 1, 1, 0. Now what is this? This is actually called gray coding. इसे क्या बोलते हैं? ग्रे कोडिंग बोलते हैं. ये ग्रे कोडिंग फिक्स होती है. ग्रे कोडिंग से आपको वैल्यू मिल जाती है बहुत फटाफट. फॉर एग्जांपल x बार y बार z बार, तो वैल्यू कितना होगा? 0. x बार y बार z कितना होगा? 1.